Good evening, everyone. Welcome to the live class. We'll be starting in a minute, hoping that the network is okay today. So let me just add the students from the WhatsApp group to the class, and then we'll start. In 2 minutes, we'll be on our way. Okay. We're almost ready. Okay. In less than okay, almost ready. I think the network today is a little bit poor, so I don't know if the network is okay from your end. Welcome to today's class once again. I've been struggling with the network ever since I tried to come live. I hope the network is okay. So today we are looking at circle theorem. Circle theorem. Okay, nice to see you, Marcia. Good evening. Francis, good evening. Humble, nice to see you. Good evening, everyone. Is the network okay from your end? Can you hear me and can you see the board clearly? Good evening, Doris. Okay. So today, as I said, we are looking at circle theorem. Circle theorem. Circle theorem. First thing we need to know is what is circle theorem. Okay. How many of you have learned about circle theorem before? Good evening, Richard. Nice to see you. Sorry, Richmond. Good evening, Victoria. Freddie Jonathan. I think today is your first time. Freddie, today is your first time. Nice to have you in the class. So let's continue. So circle theorem are geometric principles that describe the relationship between angles, lines, and points within and around a circle. So let's write it. That describe the relationship between angles, lines, and points within and around a circle. Okay. So we are going to look at these geometric principles. So for you to successfully solve questions involving circles, there are some principles that you need to obey. Good evening, Daniel. So there are some principles you need to obey in order to successfully solve questions involving circles. So we are looking at the relationship between angles, lines, and points within and around a circle. Okay, so that's basically a description of circle geometry. Good evening, Confidence. So I'd like you to write that down quickly, and then we look at each of the principles, the 7 principles, or some persons say 8 principles that are under circle theory. Okay, so we'll look at those principles today, all the principles, and then on Saturday, good evening, Ibigo, and then on Saturday, we will look at examples in that require those knowledge of those principles. Okay, so let's continue. I'm wiping this off. So we are going to look at the first principle, or the first theorem. First theorem. So the first circle theorem is angles in the same segment are equal. So this is the first principle we are looking at today. Good evening, success. Angles in the same segment are equal. So let's draw a circle. So if you have a circle like this, okay, when a line divides a circle into 2 equal parts, this line is called a diameter, right? So when a line divides a circle into 2 equal parts, the line is called a diameter. However, if you have a situation where a line divides this circle into 2 parts, one part bigger than the other part, this line is not called a diameter. The line is called a chord. So this line is called a chord. So the line that divides a circle into 2 unequal parts is called a chord. Okay. Now, when this chord divides this circle into 2 parts, these 2 parts are called segments. So a chord divides a circle into 2 segments. The bigger one is called the major segment. And the smaller one is called the minor segment. So the bigger one is called the major segment. The smaller one is called the minor segment. Good evening, Victoria. Second Victoria. Okay, so now, as we said earlier, a chord divides a circle into 2 parts. One side is bigger than the other side. The bigger one is called the major segment. The smaller one is called the minor segment. And this principle states that angles in the same segment are equal. So I'm going to clean off what I wrote. Okay, so I will look at it, look at this principle in detail. Okay. Okay, so let's look at this circle we have here. So this circle is now divided into 2 segments. This principle says that angles in the same segment are equal. So let's look at this segment. If I draw something in this form, okay, how many angles can you see touching the circumference? How many angles can you see touching the circumference? How many angles can you see touching the circumference? Three angles, okay, correct. 5. So remember, we are looking at 1 minute. So this is the uh, chord. So from this chord, a line is drawn from the beginning of this chord, touching the circumference and back here. From here, a line is drawn, touching the circumference at this point and back here. From here, a line is drawn, touching the circumference and back here. So there are 3 points, there are 3 angles that are formed. So let's call this angle A, angle B, and angle C. Okay. Now, all these angles are on the same segment. So remember, this is the major segment. So all these angles are on the same segment. Okay. So since angle A, angle B, and angle C are on the same segment, we can say that these 3 angles are equal. Okay. So angle A is equal to angle B is equal to angle C because they are on the same segment. Okay. The reason they are all equal is because they are on the same segment. Now you might have some situations where the chord will not be drawn. Okay. You might have situations where the chord will not be drawn, but you see that all of them meet at this point on the circumference and at this point on the circumference. So you can still have that image or picture. Hello, Daniel, good evening. You can still have that picture of this invisible chord. Okay. So even if you don't see the chord, you need to check if there is an invisible chord because some situations, the questions might be like this. Okay. So you can still use the principle even if you have this situation. You just know that there is an invisible chord that divides this side from this side. So I'll give you 1 minute to write and then we'll continue. Okay, I think we can continue. Okay, so let's continue. So we have looked at the first principle. Okay, therefore, someone asked, what is the difference between segment and sector? If the person is still here, please indicate so I'll know that I'm answering the question to someone that is still here. What is the difference between a segment and a sector? Okay, so let's continue. Let's look at the second. Let's look at the second principle. So as I said, we are using today's class to just go through all of them. Then in our next class on Saturday, because many questions will require your knowledge of more than one principle. So if you just know one principle, you are not well equipped to start solving questions. You need to know all the principles, then you can know which one to apply in any situation. Okay, the second principle is angles in a semicircle angles in a semicircle equal 90 degrees. Are you guys still here or the network is bad? Okay, so now let's look at this situation. So first we need to know how a semicircle is formed. A semicircle is formed when a diameter cuts through a circle. So if you have the center of the circle here, and you have a diameter, now each of these parts is a semicircle, okay? Each of these parts, here is a semicircle, here is a semicircle. When the line passes through the center, which is called a diameter. So this is a semicircle, this is a semicircle. The principle states that angles in a semicircle equals 90 degrees. So in the first situation, we are not dealing with semicircle, we are dealing with segments. But in this situation, because a diameter is involved and not a chord, we are dealing with semicircle. So here, if you have an angle like this, in this situation, each of these angles equal 90 degrees. So when you see a question on circle theorem and you discover that the line that is dividing the circle is a diameter, you might not need to be told that this is 90 degrees. So once you see that this is a diameter, you should know that this angle here is 90 degrees. So here is 90 degrees, here is 90 degrees. So when angles are on a diameter, that angle is 90 degrees, okay? When the angles are on a chord which produces a segment, then that angle, all those angles are equal, but they are not necessarily 90 degrees, okay? The angles for the first principle, all the angles are equal, but they are not 90 degrees. But in this situation, they are 90 degrees, okay? So that's the second principle. If you have any question to ask, please go ahead to do that. So let's continue. So this is the second principle, right? So let's go to the third principle. If we can go through them quickly enough, we can look at one example. If we can go through them quickly enough. Let's see. Okay, I think when we go through the third example, the third principle, we are going to, let's try to solve one example, okay? So 3. Angle at the center is twice angle at the circumference. Angle at the center is twice the angle at the circumference. Okay, so if you have a situation like this, and then you have a chord, here is the center. So the angle that a chord makes with the center and the angle that same chord makes with the circumference the angle here is twice the angle here. So if here is x, here will be 2x. So angle at the center is twice the value of the angle at the circumference. Eva, good evening. Nice to see you. So the angle at the center is twice the angle at the circumference. Okay. So it might not necessarily be like this. Okay. Let's look at a situation. I'm going to draw this again. You might have a situation where it looks like this. Okay. So it's not looking straight. It's just this way. But since both of them are on the same chord, the angle here is twice the angle here. So it doesn't have to be straight, okay? It can be slanting. But once they are both coming from the same chord, one of them touching the center and the other one touching the circumference, then the one at the center is twice the one at the circumference. And remember, you might not be given this line. Okay? So you might not be given that line. So it might just be like this, but you still know that there is an invisible chord. Okay? So whichever way is the same thing. As long as one is at the center and one is at the circumference, angle at the center is twice the angle at the circumference. Okay, so should we look at an example? Just one example before we continue. I'd like to hear from you guys. Should we look at one example? From the ones that we've already looked at, should we consider one example? Seems you guys are already sleeping because there's no example. Okay. Richmond said yes. Okay. Who else? Any other response? Today's class seems to be dull because we don't have much examples. Any other response? Yes, no, yes, no, yes. Okay. Let's look at one example. So the example we're going to consider will be from one of the three principles that we have already looked at today. Looked at this point. Example. Okay, so we have A, B, C, and D. So we're expected to find the value of angle ABD. Angle ABD is this angle here. Okay, Freddy said it's active. There are some persons who have been attending the class but have not contacted me on WhatsApp. I'm still reminding you about that. Please contact me on WhatsApp so I can save your number. Else, when I'm deleting the numbers of those that I have not saved, I will also delete your number, even though you have been in the class. Okay. Okay, so now let's look at this. We're expected to find the value of angle ABD, which is this angle here. Let's call it X. Okay. So now, for us to find that, we can see that we are given an angle here, 105 degrees. Hope you can see it. This is 105 degrees. So for us to find this angle, first we need to find this angle. What principle are we going to use to find this angle? From all that we have been learning in all our classes, what are we going to use to find this angle? And what will be the value of that angle? So previous knowledge also can be used here. Read vibes. Teta, I think have you contacted me on WhatsApp? Angle on a straight line, correct? So you can see that a previous knowledge is being used here. Chidera, nice to see you. A previous knowledge is being used here. This is angle on a straight line. So if here is 105 degrees, here will also be, here will be 180 degrees minus 105 degrees. So here will be 75 degrees. So we can say that angle DCA is equal to 75 degrees. Okay, so we have gotten that value, but we're expected to find this. Now, from today's lesson, can we say that this angle and this angle are on the same segment? Can we say that this angle and this angle are on the same segment? Are they on the same segment? X is equal to 75 degrees, correct. So if I draw, remember I told you that sometimes the chord might be invisible. So if I draw a chord like this, this was an invisible chord. This is the center. It wasn't passing through the center, so it's a chord, right? So this is the minor segment. This is the major segment. So we can see that these two angles are in the same segment. So we can use the first principle that states that angles on the same segment or angles in the same segment are equal. So this angle here and this angle here are on the same segment. So we can simply say angle DCA is equal to angle ABD or ABD, right? Angle DCA is equal to angle ABD, angles on the same segment or angles in the same segment. Same segment. Therefore, angle ABD is equal to 75 degrees. So that gives us the answer, 75 degrees. Okay, so that's just to warm us up to know that there are more questions to be solved while we go looking at the other principles. So we've considered 3 principles at this point. We are going to look at principle number 4. Can we continue? Can we continue? Can we continue? So this is very important. Sometimes you might not see the chord. So it's important that you are able to locate it where it is. Okay? So let's continue. So number 4 principle. The opposite angles in a cyclic quadrilateral are the opposite angles in a cyclic quadrilateral sum up to 180 degrees. What you have to do is you have to watch the live class again. I will not be able to go back to it that will not be time efficient because I have just 1 hour before my one-on-one tutorial. Okay, let's look at number 4. The opposite angles in a cyclic quadrilateral sum up to 180 degrees. So the opposite angles in a cyclic quadrilateral sum up to 180 degrees. So cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral that is enclosed by a circle. Remember, a quadrilateral is a four-sided plane shape. So when a four-sided plane shape is enclosed in a circle, that four-sided plane shape is called a cyclic quadrilateral. So if you have so, and for it to be a cyclic quadrilateral, all the vertices, all the edges must touch the circumference. So if any of the four edges does not touch the circumference, then you cannot call it a cyclic quadrilateral. Okay, so all the four edges must touch the circumference. So this principle states that if this is angle A, this is angle B, this is angle C, and this is angle D. This principle states that the opposite angles in this cyclic quadrilateral, when you add them together, you're going to have 180 degrees. This means that angle A plus angle C opposite is equal to 180 degrees. Also, angle B plus angle D equal to 180 degrees. Okay? So it's a simple principle. But most times when you see a question in circle geometry, if you don't have understanding of these different principles, you might find it confusing. That's why we need to go through all the principles before we start solving questions. So that when you begin to see the questions, you can begin to pick out the principles that will help you solve each question that you come across. Okay? So this is principle number 4. The opposite angles in a cyclic quadrilateral sum up to 180 degrees. So we're going to look at principle number 5. We're almost there. We are doing well. So I'm wiping this off. So as I said, in our next class, we'll focus on calculations, solving questions, solving questions, solving questions. I don't know what grade this is in your country, because we don't call it grade in my country. Okay, so now let's look at, this is principle number 6. Is this 6? Is it 1, 2, 3, 4, 5? 5. Okay. A tangent meets a radius of a circle at 90 degrees. So this is principle number 5. A tangent, we are following an arranged system. So I don't teach jumping from one topic to the other. My major focus is basic mathematics, not calculus. In my country, it's called further maths, not further maths. because not many people need that. I'm teaching topics that many people need. So, a tangent meets a radius of a circle at 90 degrees. Let's look at that. So if I have something like this, first of all, we need to know what a tangent is. A tangent is a straight line that touches a circle at one point. So my circle is not perfect, actually. The drawing is not perfect. So don't use manga. So, but a tangent is a straight line that meets or touches a circle at one point. So if I have a line like this, so if this line touches this circle at this point, it seems the network is bad. I could do that. I could do all those topics when I'm done with what I'm doing. I'm following a textbook. I showed you guys the textbook some time ago, and that is just basic mathematics. It's not further math. So I should have gone through those. If you're going to be patient for the next 1 year, probably we're going to get to that, because the idea is uh, I'm going to teach from one topic to the other for the next 1 year, depending on the seriousness of the students. But it seems that many of the students in the WhatsApp group are not serious. So it's a little bit discouraging, yeah, because I spend my time, energy, money, but I'm not seeing the seriousness, probably because they are not paying for it. So since they are not paying for it, many persons are not serious. But I'm grateful for you guys that are serious. So now let's look at this. If you have a circle here, this is the center of this circle. Remember, a radius is a line drawn from the center of the circle to the circumference of the circle. So if you draw a radius like this to this point, at the point where the radius and the tangent meet, this is the tangent. So at this point where the radius and the tangent meet, they form a 90 degrees. Okay. So whenever you see a radius and a tangent meet each other, you should know that that angle there is 90 degrees. Okay. One of my students, one of my one-on-one students asked me, what if the radius, because the radius can be any direction, what if the radius is this way? And what if they meet together? Will they form 90 degrees here? I said it's impossible for the radius to meet the tangent at this point because the tangent only touches the circle at one point. So it's only possible for the tangent to touch the circle at one point. If a line touches the circle at more than one point, then you cannot call it a tangent. Okay. So if a line touches a circle more than one point, it is not a tangent. Yeah, that textbook is also a very good textbook. I used to use that textbook. It's also a good textbook. Okay, so it's not possible for the radius to meet the tangent like this because you discover that at this point, the radius and the tangent are not touching each other because this is the radius cannot go beyond the circumference of the circle. The limit of the radius is the circumference of the circle. You cannot draw a radius and it will pass the circumference. No, it stops at the circumference, right? So over here, the radius and the tangent cannot touch each other. You can only touch the tangent where the tangent touches the circle. Okay. So this principle states that a tangent meets a radius of a circle at 90 degrees. So take note of that principle. We're almost done. We're almost done with the principles. Let's look at number 6. Number 6. tangents from the same point touch the circum sorry, sorry. Tangent from the same point are equal in length. I think that should be better stated. Tangent from the same point are equal in length. So if I have a circle like this, and then I have a point here, this is the point, and then from this point, there's a line that touches the circumference, and from this point, oh, my drawing, I need to do better with my drawing. Okay, so if this is point P, and then this line touches the circumference here, and touches the circumference here, the distance from, let's call this Q and R. So the distance from Q to R, so the distance from Q to P is the same as the distance from R to P. They are the same distance. So if from the same point you draw two tangents that touch the circle, wherever they touch the circle, the distance from P to R is the same as the distance from P to Q. Hope that is understood. So the two distances are equal. So you might have a situation where you're expected to find the length. So you should know that those two lengths are equal. Okay. So let's look at the next one. The next principle comes out from this principle. So if you draw a line from the center of this circle to the point P, if you draw a line from the center of this circle to the point P, that line bisects whatever angle you have here. You know what it means to bisect? To bisect means to divide an angle into two, okay? Divide an angle or divide a line into two equal parts. So if you have this arrangement, if you draw a line from the center to touch point P, that line is going to cut this angle into two equal parts. Okay, so it's like a subset of this principle. So you need to take note of that. So let's look at the final one. I know today many of you are bored because we did not do much calculation. Let's look at the final one. And then we'll solve one question for today, one more question for today. And then on Saturday, we focus on solving questions throughout the class. Throughout the duration of the class. Okay, so number 7. This principle is called the alternate segment theorem. This states that the angle the segment makes with the chord is equal to the angle the chord makes with the circumference. The time for Saturday's class is 6 p.m. Nigerian time. Okay. So this principle states that the angle the tangent makes with the chord is equal to the angle the chord makes with the circumference. So let's draw something. So if we have something like this, and then we draw a tangent, and then if we have a line like this, what's this line called? Who can remind us what this line is called? Who can remind us what this line is called? You're welcome, Benjamin. Benjamin, are you from the WhatsApp group? What's this line called? Chord, correct. So this principle says that the angle the tangent, this tangent makes with this chord. This is the angle. This tangent and this chord make this angle, right? It's equal to the angle this chord makes with the circumference. So this chord makes this angle with this circumference. So if we call this angle BA, I'll call this angle B. Read the statement again. This states that the angle the tangent makes with the chord, angle A. The angle the tangent makes with the chord is called angle A, because this is the tangent and this is the chord. Is equal to the angle the chord makes with the circumference. So this chord makes this angle with the circumference. Okay, so these two angles are equal. So angle A is equal to angle B. On the other hand, we can also say that this is a chord. Do you guys agree that this is a chord? Do we agree that this is a chord? Do you agree that this is a chord? Good. So this is a chord, and this chord makes an angle. Let's call this angle C with this same tangent. So this tangent makes this angle with this chord, and then this chord makes this angle with the circumference. So if we call this angle D, we can say angle C is equal to angle D, because this chord, this tangent makes this angle with this chord, and this chord makes this angle with this circumference. I repeat, angle A is a chord that is, angle A is an angle that is produced by this tangent and this chord. Angle B is an angle produced by this chord and the circumference. Therefore, they are equal. Since the same chord is involved, the same chord produces angle A, this same chord produces angle C, angle B, therefore angle A and B are equal. Also, this is a chord. This chord produces angle C in combination with this tangent. This chord also produces angle D when it's combined with this circumference. So angle C and angle D are equal. So this is called the alternate segment theorem. Okay, so angle C is in the smaller segment, angle D is in the major segment, angle C is in the minor segment. So that's why it's called the alternate segment theorem. Okay, angle A is in the minor segment, angle B is in the major segment. Okay, Ryan, good evening. Welcome. though you came late today. Okay, so we are going to solve one question. That's if we have time, because my student just sent me a message. Give me a minute, let me respond. Okay. I was experiencing that earlier too. I thank God that I almost sent a message to the WhatsApp group that will not have class today. I just decided to try it again and it went through. Okay, so let's see. Can we solve this question in 5 minutes? Let's try. Let's try. Okay. So we are looking for angle BCF. Okay, let's draw it. When will I know how to draw? This one to be something else. This might not look like the center, but it's actually the center, okay? Okay, let's try this out. So we're expected to find angle BCF. BC, oh, sorry, F. That means we're expected to find this angle. That's the angle we're expected to find. Okay, so let's look at it. Now, from our previous knowledge, triangle ACD. Triangle ACD, what type of triangle is that? Triangle ACD. What type of triangle is triangle ACD? What type of triangle is triangle ACD? Does anybody know? With these two signs we are seeing here, when we learned about triangles, with these two signs, what type of triangle is that? Isosceles triangle, correct. Isosceles triangle is a triangle that has two equal sides. That means these two sides are equal. Since those two sides are equal, that means these two angles facing there are equal. So if angle CAD is equal to 35 degrees, that means, oh, my student is already calling me. Give me a minute. Hello, Aku. Hello. Can you hear me, Aku? Okay, we're going to start in 10 minutes. Please give me 10 minutes. I'll call you back. Okay, I'll call you back in 10 minutes. Thank you. Oh, sorry. So we have to finish in less than 10 minutes. Okay, so it's quite easy if you know the principles. So we know that if this angle is 35 degrees, angle DCA is equal to angle A. So if that angle is 35, oh, it seems the network has gone bad. So if that angle is 35, if these two angles are 35 degrees, this angle here will be 180 minus 35 degrees. 180 minus 35 degrees is 110 degrees. 110 degrees. Okay. And we know that from the principles we've learned, we can call this A, B, C, D a cyclic quadrilateral. Is this a cyclic quadrilateral? Is this a cyclic quadrilateral? Are you there? Has the internet disconnected? Okay, I'm just going to go ahead to conclude the class. So this is a cyclic quadrilateral, and we learned that opposite angles of a cyclic quadrilateral equal to 180 degrees. So if this is 110 degrees, this angle plus angle at B, they are equal to 180 degrees. So that means this angle is what? 70 degrees. Okay. 70 degrees. Can we continue? I think this network has gone bad. We'll continue in our next class. I don't know, the network is quite bad over here. I don't know if you guys are even hearing me. Sorry that we have to end at this point. I need to check my internet connection. We'll continue from this example in our next class, please, so that we'll carefully look at it. We'll continue in the next class with this example. Okay? On Saturday, 6 p.m. Nigerian time. Thank you, guys. See you in the next class.